Today we're going to start with rhombus. A rhombus is a type of parallelogram. So we're going to start by writing that out. A rhombus is a type of parallelogram. So all of our theorems for parallelograms also apply to rhombi. What is rhombi? Miss Sutter explained it, but a lot of you were talking. A group of, it's just the plural of rhombuses, yeah. Good.
Why isn't rhombuses?
It's kind of a silly, I don't know, Miss Sutter could probably, she's really good at linguistics.
Words that end with that US, like in octopus, you change the plural to I instead of S, it's just because it sounds funny.
Alright, something that we know about a rhombus is that all sides are congruent. Does anyone remember, what do we call a polygon that has all sides the same? What do we call a polygon where all the sides are the same?
Quadrilateral.
Quadrilateral is just four sides. Equilateral. Alright, so I'm going to show that all sides are congruent. So A to B is congruent to B to C, which is congruent to C to D, which is congruent to D to A. So all four sides are equal. They're all the same. Here you go. Okay. Alright, something else is we know that the diagonals are perpendicular. Diagonals are perpendicular. What does it mean if two things are perpendicular to each other? Not congruent. You can keep it. Perpendicular, what does it mean that they're perpendicular?
We often pair that word with parallel. Yeah, they cross through each other in what way? Are any two lines that cross each other perpendicular? No. What do they have to make when they cross? 90 degrees.
Good. So in this picture, which ones are our diagonals? Who can name one of the diagonals? A to... What's another diagonal? B to D. So where these cross is 90 degrees. All these insides, all these angles are 90 degrees. Alright, something that's really, really, really important about a rhombus that is probably new for you today is that the diagonals bisect the angles, yeah.
Oh my Lord.
It's overheated, I think. Diagonals bisect the angles. So we've talked about that word bisect a lot lately. Does anyone remember what does bisect mean? It goes through exactly in the middle. Yep, cuts it right down the middle in half. So when we look at these angles, I'm going to look at angle A first. So angle A of the rhombus would be this whole angle, BAD. Angle bad. But that red line cuts that angle right down the middle. So those two smaller angles, BAP and PAD, are going to be congruent. So this angle here will be congruent to this angle here. That's purple. And then because it's a parallelogram, what other angles do we know are going to be congruent then? The angles at B, C, or D. Which other angles will be congruent to A? C, the ones opposite. So over at C, all of these little angles will also end up being congruent because we're taking the same angle and splitting it in half. So all 4 of these end up being the same amount. Okay, and then same thing happens with our angles at B and D. So at B, we're going to take that whole angle, that diagonal cuts it right down the middle. So this angle, we'll use 2 little rings that time. 2 swoops will be congruent to this angle over here. And same thing at angle D. Alright, next up we are going to glue in the rhombus that has the DKAML. The one with just it in right next. Pass those glue sticks around. Oh my goodness. What? Oh no. How are you ever going to survive? Oh man. Oh no. Alright. Okay, we're going to get started, so get it glued in. We're moving on with our lives. Going. Alright. First thing we need to do with this rhombus is let's name it. So, to name a rhombus, we need the outside corners. And it has to make sure that we are working our way around the outside. So, which letter would you guys like to start at? D, K, L, or M? D? Okay.
K.
You want to start K? Okay, we got 2 votes. We got a D and a K. What do you guys want?
K.
D? Okay, I'm hearing more Ds. Alright, so D. Now, at D, we have 2 options. We can either go D to K, or we can do D to M. So do you want it to be DK or DM?
K.
I heard like half and half. We'll go with K. So do D to K. Now at K, we only have 1 option. What's the next letter that has to go next? L. And then what's our last letter? M. So DKLM is a rhombus. That's really important that when we get these problems, we read the directions to see what kind of shape we're dealing with. If we don't know what kind of shape we're dealing with, we don't know which properties we can use. Okay. All right, number 1. We have 3 problems we're going to do with this picture, and then we'll do a picture, and then we got just a small thing about squares. If DK is 7 centimeters, what is MD? If DK is 7 centimeters, how much will MD be?
What now? Where now? K.
Good. First thing to do, Christian, is what? What now? Where now?
What now? Where now?
Let's find it. So, we want to find DK. We're talking about a line segment here, so D to K is this line up here. That's 7. We're given that. find MD. Where's MD? Yep, right here. So what would that segment be?
I'm gonna say DM.
One.
Because it looks literally.
Oh, you're going by look.
It looks like a longer.
Uh-oh, don't go by look. What do we know?
All the sides of a rhombus are equal.
We know that all the sides of a rhombus are equal. So if 1 is 7, what are the rest? 7. So even if the picture looks wonky.
So MD is 7, what? Degrees? Feet? Centimeters. So length, forget. It'd be 0.0007 kilometers. Alright, number 2. If MK is 18 centimeters, then what is MA?
Alright, let's find that first. So we're looking for MK. MK is the line right here.
Nine.
What's that kind of line called?
It goes,
Diagonal. Yep, this is the diagonal. And what does the diagonal do? You said it. Splits it. Yeah, exactly. So that's going to help us. So
Purple.
MK is 18.
I'm doing light blue today.
We want to find MA,
Which is 9.
which is 9. How'd you do that?
Because I split MK in half because it's split.
Yeah, and when you split it into parts, you divide. Very good.
Good, and because it's a parallelogram, we know that it's split into 2 equal parts. Amazing. So we're going to do 18 split into 2, so divided by 2, and we get 9. So MA is 9 centimeters. In chapter 9 we might.
Will I have to show my work?
On chapter 9, yeah, you would.
Kind of like drawing.
It's drawing, you can't really not show your work. Your work is is the problem.
I have to.
Alright, number 3. Last one with this one, and then we'll move on to a different picture. Alright, these next ones are going to have to do with angles, and really with angles we have to be really careful about how we name angles and how we look at the angles. So in this one we're going to say if the measure, so for measure we use a lowercase m, of angle LKA is 36 degrees. I want to know what would be the measure of angle KDM. You sure?
No, I'm not sure. No, they already done it.
They're not. Alright, first thing to do is what?
No, all set.
Starts with an L, ends in okay.
Let's find what we're looking for.
Locate.
Locate.
Ooh.
So we're going to locate LKA. So remember, when we have an angle, these are 3 points. This shows us how we're going to move. So we're going to start at the L, move to the K, and then move to the A. So LKA. So we're actually looking at this little part right in here. That's 36. And we want to find KDM. So start at the K, move to D, and down to M. We want to find this whole part, both of these together.
Oh, that's right.
All right, so let's think about what we know and what we could do to find that whole green part.
So what other angle do we know right off the bat? L?
I think I heard M.
Kind of, yeah. What's going to be on the other side of that diagonal? How much is right here?
Oh, DK. I was thinking DAM.
36.
36.
Because it's cut into congruent. You got it?
Good. I'm going to just make a quick sketch of this down here. D, K, L, M. There's kind of a couple ways to find this. We're going to talk about one way in this example. We'll do a different way in the next one. So if I look at all of angle K, this whole thing, how much is this whole thing of angle K? I have a 36 and a 36, which makes 72. What? 72. Yeah, we're getting there. Just breathe. How did you get 108, Christian?
Well, because 36 plus, so M, angle M has to match K, so that'd be 36, and then 36 to 36, 72, then you did that, and it has to equal 180, so like 108 plus 72 equals 180.
Okay, so you kind of looked at it as a triangle, actually.
Yep.
Okay, cool. I'm going to look at it as a parallelogram. You got it. Alright, as a parallelogram, what do I know about angle K and D? Are they opposite or consecutive? Consecutive. And what do we know about consecutive angles in a parallelogram? Supplementary. So, if they're supplementary, how can I find angle D if I know angle K is 72? Subtract. 180 minus 72, which is 108. So we get the same answer as Christian. He figured it out a different way, which is totally fine. So measure of angle KDM. Since we're measuring something, we do need a label. Is it 108 feet, 108 centimeters, 108 degrees? All right, we have one more example with a rhombus. Is this ABC with the numbers on it? So go ahead and glue that one in, and then we just have a really short talk about squares. So we're doing that ABCD rhombus with the numbers on it. Yep. So we'll get that one glued in. Share glue sticks, but make sure they get back to the right tables. If you're passing around from table to table, somehow this table always has one.
Unless I did it.
You did it. You did the square. Do that one on the next page, Layla.
Why?
Because we're doing the rhombus.
Oh, actually, I'm in the wrong one.
So put that, yeah. So put that one on the next page.
Oh, it's so much longer. I'm sick and tired
Okay.
of it. No.
Alright, in this one, we need to find the angles that are missing. So there are 4 angles here. We're going to find what is the measure of angle 1, measure of angle 2, measure of angle 3, and the measure of angle 4. Do we need to go in numerical order when we find these? Do we have to start at angle 1? No, we can do whichever one makes the most sense. So which angle might we be able to do without having to do a lot of math, without having to add, subtract, multiply, divide? 4? Okay, what about angle 4? What do we know with angle 4? It's in the middle. And in the middle, it's always on a rhombus, 90 degrees. So angle 4 is 90. Is there another angle that we know pretty close without having to do too much work? We can do angle 3. It's going to be a little bit quicker. It's not necessary that you do 3 before 1, though. But what we know about 3 is it's this part down here is the same as the part above it. But what other angles are they also congruent to? The other side. So it's congruent to this one and this one. And I know one of them, which tells me that all 4 of them are equal to 32. They're each 32 degrees. Alright, now for 1 and 2, we could think of it back to a parallelogram and put 32 and 32 together and then figure out what this would be and then have to split it up. Another way we can do it is similar to what Christian did in the last one. We can look at it as a triangle, and I'm going to look at it as just this triangle here.
Oh, it's 58.
Yep. You got it. So in that triangle, I'm just going to redraw it over here. I know that this angle is 32, so I'm going to put 32 in that corner. What was angle 4? 90. And this is the one that I'm trying to find. Subtract from what? Yeah, all together in a triangle, they all make 180. So, to find that missing part, we can do 180 minus 90 minus 32. And what's 180 minus 90 minus 32? 58. So angle 1 will be 58 degrees. What about angle 2? The same. 58 degrees. Alright, we have a very, very short amount left, so we can finish this before lunch, which will be great, because then when you get back, you can just work on your practice. Alright, you're going to go ahead and glue in that square. I have to go to the next page. We're just going to talk about squares. A lot of people have experienced squares before in their lives, so we don't need to super talk about it. We're just going to name a couple things about it. Yeah, if you write small. Alright, so this one is a square. Alright, with a square, a couple of things that we know. What's something you guys all know about squares? All sides are equal, or we could say congruent. What do we call that when a shape has all sides the same? Equilateral. If you'd like to mark that up, I didn't put that on the sheet here. All sides are the same. What else do we know about a square? All 90-degree angles. Also equal angular? Somebody say that? Awesome. Now, there was a special word back in that chapter 6 introduction that Miss Ryder did with you. I was gone on that day. But that told us that a shape was both equilateral and equiangular at the same time.
Regular shape.
Regular. So this is a regular, what kind of polygon is it? How many sides?
Square down.
4. So a regular quadrilateral. Alright, now when we do these classifications, it's kind of like with animals. If we think about animals, we would start with a really big idea. We'd start with the idea animal. Then we could narrow it down and say a mammal. Then we could pick a type of mammal like a bear. And then we can even pick more specifically a bear like a grizzly bear, right? So it's kind of the same thing here. We're going to start with the big idea. It's a quadrilateral. Is it a parallelogram? Are the opposite sides parallel? Okay, so it's a quadrilateral. It's a parallelogram. Yesterday we learned about rectangles. Is it a rectangle? Yeah, yes. What was the definition of a rectangle? Yeah, a parallelogram with 90-degree corners. Does it have 90-degree corners? Yep, so it's a rectangle. Is it a rhombus? Yep, a rhombus is a parallelogram with equal sides. So when it's all four of these things, it's also a square. Oh, so close. Alright, and that's it for notes. When you come back from lunch, you'll do your practice. Cool. Make sure you get that on. Okay, bye.